We're very excited, first of all, by the work that we were able to do thanks to the support of the family and the 401 project. What we have been able to do is answer the question, is the duplication syndrome reversible? How do you know if it's reversible? What you do is you let the animals develop all the symptoms that we typically see that are very reminiscent of the features we see in the human patients. And after they developed all the symptoms, we take one of the extra genes away genetically. We turn it off, and once we turn it off, we get back the mouse to have just one copy of MECP2. And what we saw with time, as we did that, the animals got better and better. And basically all the symptoms we saw in them with the duplication slowly disappeared. So this was very encouraging. This was very exciting to us. The brain can recover when you take away the extra copy of the gene. What this did, it then inspired us to explore a new potential therapeutic approach that we had not considered before, which has gradually been tested in some various models of neurological diseases to regulate levels of proteins or to really target specific genes within a cell. And that technology is called antisense oligonucleotides, which means they're little pieces of DNA that can bind to a particular gene and lower its level. And in this particular case, we wanted to test if we can use this little piece of DNA that we can deliver into the brain and see if we can lower the levels of MECP2. Why did we want to test this? We wanted to test this because this is something you can test in human patients. Genetic rescue, where you manipulate the genome, is not something we can do in humans. So we really needed to move from things we can only engineer and do in mice to something we can now perhaps one day do in a clinic in a patient. That's why we tested these antisense oligonucleotides. And once we established they can do so, we then implanted them in a little cannula. We gave them via the ventricle because you have to get it to the brain. This is not something you can give in the blood and it'll get to the brain. It took a few weeks for the protein level to get back to normal. But the very nice thing is that as the protein level stayed normal for about 4 weeks, we gradually started seeing the symptoms go away and the animals improved. What we will have to do now is make this mouse now with both of its copies coming from the human gene to titrate, and we'll have to test a lot more of these small DNA pieces to find the perfect one with the minimal toxicity. Once we have that established, we will then go to a non-human primate model to test it further, and only after that we will be ready to move things into the human. So this is one of the projects that was funded by the 401 project that yielded very exciting fruits that we have now a path forward to.